My name is Amir Kaushansky, and I'm heading the cloud network security at Check Point. And the topic that I'm going to cover is containers and serverless security. And Tzion, TJ, he will join this session, so we'll do it together. Tzion was the CEO of Portego. So he's going to share the serverless part of the presentation. And while I log in, I will start, to tell you kind of the story that usually when I start a presentation, I like to start with introducing myself. So again, my name is Amir, and I used to work for Check Point between 2002 to 2008. And then I left Check Point, and I went to a different market, the lawful interception market. And back then, the lawful interception market was kind of simple, very, very simple, because people were, the agencies were intercepting mainly phone calls. And it was quite easy, because if you were a target, you had to go, and when you had to call someone, to communicate with someone, you didn't have a lot of options. So you had a phone at your house, they were intercepting your calls, there was only one protocol, and it was quite easy. You had 5, 6 calls a day, and that's it. So it was not so challenging to intercept everyone. And then a few years later, if we look at, let's say, 5 years ago, 6 years ago, there was a paradigm shift in the lawful interception market. And this paradigm shift was due to the appearance of smartphones. Okay, so when smartphone appeared, lawful interception was the market, the agencies were kind of shocked, because then targets had the option to use applications, and their popularity changed a lot, and then applications became encrypted. So the lawful interception market was overwhelmed by that. They didn't have the manpower, they didn't have the capacity, they didn't have the technology to deal. Voila. They didn't have the technology to deal with that. And I claim that we are in a paradigm shift in IT. So if you look at modern IT environments, right, they look different from what they used to be. And the driver for that is agility, speed. Developers like it, CFOs like it, everyone likes it, because you pay as much as you use. For example, here we use Lambda in this architecture. You don't pay for the compute, you don't pay for the electricity, you just pay for the number of times that the Lambda is executed and the number of seconds that it was running, or milliseconds. Procurement is not an issue anymore. So who ordered servers in the past and had to wait 3 months till they come and go through customs, and it's a pain in the ass. And then you need to find a place in the rack to put it. Seconds. You just go to the AWS marketplace, you book it, you get it. That's it. And then these type of architectures allow you to change the way that the software is developed, right? You can build these small development teams. The only thing that is common between them is the API. They can run in their own phase. And this is why you can deliver today applications 5 times a day, five times a week. You don't need to wait for the entire cycle to release a version once in a quarter or once in a year. You can really develop and do it very, very fast. And everything is a click away from production. You have your CI/CD pipeline. From the CI/CD pipeline, you can click publish, and it will go to production immediately. You don't have any guardrails. You have guardrails, but you don't have anyone. You don't have this process that you need someone to validate it, and then someone to approve it and put it in production and define all the networking and capabilities. It's just a click away from production. And I claim that as technology evolves, the CISO is losing control. Okay? The speed of change in these technologies is fast. The configuration is changing all the time. The code is changing all the time. new services come, they implement new services, so everything changed very fast. Developer is the king. He controls everything. He decides what to do, how to do, and the CISO is unaware, and it doesn't have the ability to control it. And when we used to have a perimeter, a well-defined perimeter, and it was quite easy to put controls in this perimeter, right now you have many perimeters. Okay, so your S3 is a perimeter. And then your other PaaS services are perimeters. And each Lambda function is a perimeter, right? So you have a lot of perimeters that you need to control, and it's very, very challenging. But if you look at this landscape, you have the same security needs, right? If in the past we did posture management, we need to do posture management here as well. If we did workload protection, we need to do workload protection here as well. Network and also log analysis. We need to do it no matter what, how we run it. If we run it on bare metal or we run it as a serverless form factor. But there are specific security challenges that are specific for these domains, containers and serverless. And I will go through them and share with you the high level of it. So first of all, there is no visibility. As I mentioned before, everything is running really, really fast. You don't really know what's running right now. You don't have visibility into the type of workloads. You don't have visibility into the content of the workloads. And it's very, very challenging to secure something that you don't know what you're securing. I mentioned it before, there is no single perimeter. So now you have to control and manage and secure a lot of perimeters, different perimeters. Misconfiguration, because you have a lot of assets, misconfiguration might happen. So you need to deal with that as well. In these environments, in order to run really, really fast, your development teams are using a lot of open source stuff. And open source is vulnerable. Your developers are maybe excellent in developing, but are they really excellent in security? I doubt it. And then this leads to a fact that you're as secure as your weakest link, right? If you build an application from different microservices, different pieces of code, if someone hacks to one of it, then your entire application is compromised. And the same, and then someone can go and run privilege escalation and own your entire operation, either the entire cluster or the entire organization. So these are the technical kind of challenges that you have. But there is another challenge, and this is something that I see in many, many customers that I meet. Who's responsible? Who's really responsible for securing this? Is it the security professionals or the developers, the DevOps, the developers themselves? And if you think that it's something that we say and to scare you to go and try to find the solutions, these are just two examples of things that happened this year. So who knows what a container registry is? Okay, so a container registry basically is a place where your development team goes and take images. They take images to use for their own creation of images. And Docker Hub, which is one of the most common container registries, was hacked. And 190,000 accounts were compromised. And they claim that people might tampered with containers. What's the meaning of that? It means that I can go there as an attacker. I can take Nginx. I can create my own version and push it to Docker Hub. And you can use my Nginx. And my Nginx will do exactly what Nginx does. But it might contain a small piece of code that will do Bitcoin mining. It can be a backdoor for me. And you can use it and run it in your production, and you can be unaware of it. So sanitation is very important, and we'll touch it later. The second thing which happened this year is Kubernetes. And Kubernetes is the container orchestration, it's de facto container orchestration platform. And it's vulnerable. So it had a vulnerability that you could run a container and you thought that it's running in non-privileged mode, but in fact it was running in privileged mode. So imagine the use case I mentioned before, that you have a lot of microservices building your application, and you're a CISO, and you say, my risk is not that high. If someone compromises this piece of code, this specific microservice, I don't care. You know, he will live in the boundaries of this microservice. This is not the case here. If I compromise this simple container that you have, I own the entire environment. Okay, so this is why it's very, very important, and we'll talk about what we can do in order to mitigate that as well. So when we talk about cloud, our goal at Check Point is to secure your cloud journey at any stage. And we don't care if you run your form factor in a VM or in serverless or in a Docker container, we want to secure it. And the way that we do it with these 4 pillars. Okay, so these 4 pillars are the posture management, workload protection, network security, and threat hunting and log analysis. Okay, this is the only thing you need to remember. And now let's go through each one, and I will share with you what we're doing today, what we're developing, and what will come in the future. So let's start with posture management. So if we look at posture management, we do it today. Okay, this is something that is available today. You can go to our posture management system, which is Dome9, and it helps you to prevent misconfiguration. It provides visibility into your cloud assets, and it has built-in compliance rules. So you don't need to write everything. It's just there. You just need to run it. And this is example. This is something that we released recently. It's called it's the support of Kubernetes. So basically, what we do there is we give you a pod that you deploy on one of your worker nodes, just one of the worker nodes in the cluster. And then we send all the configuration to Dome9. We give you the ability to see what you're actually running. And then you can reason about it. You can say, I want to see if my containers are running in privilege mode. Tell me which containers are running in privilege mode, which is very, very important. So that's already there, and go and play with it. The second thing that we are announcing, and you can see it in the tech room, is the ability to scan containers. And the idea is that we scan the containers for vulnerabilities. Both a container is built basically from 3 layers. One is the base layer, the other one is the open source or dependencies, and the third one is the application. We scan all these layers, and we give you kind of an assessment to say, what are the vulnerabilities that you have? We give you the ability to know what is the bill of materials for each container that you're running. So if you're the CISO and you don't know what's running there, you will be able to see it. And then we use our threat intel to kind of search your configuration files and see if you have something malicious in them as well. And this is an API. It has an API, so you can plumb it to your CI/CD pipeline. We give you the ability to deploy a pod. It's a privileged pod that you need to run on each worker node. And we do this magic on the worker node, or you can do it on your CI/CD pipeline, and I urge you to go and try it. The last piece that we just released recently is the ability to scan your application code. This is something that we support from the CI/CD pipeline. You plumb your CI/CD pipeline to our SaaS service. And basically, we look for open source vulnerabilities. We look for leak credentials and tokens inside your code. And we look for possible security flaws in the code itself. For example, let's say that you have a Python application that gets a command from a command line. we can tell you, it's not a good practice to do that because you need to validate the commands that your application is getting. So that's an example. So these are the three things we do regarding serverless and containers in posture management. And now we move to workload protection. And this is a new capability for us. Zion will elaborate on that. But we're looking beyond serverless, also for virtual machines and Dockers. And again, this is something that we have in the tech room, so you can go and see it. Basically, we deploy an agent on the worker node itself. And then we have built-in threat rules. For example, if someone is trying to tamper with the security controls of the host itself, we notify you that someone is trying to do that, which is a bad practice in security. We build a baseline for each workload. So if you have containers, we build a baseline per container. The baseline is based on the behavior, OS level, processes, file system. We build a baseline of that. And then if you're moving from this baseline, or if your workload is moving from this baseline, we can detect it, or we can prevent this activity. And we are not only protecting the workload itself, we also protect the host against malicious activities. And we are in beta phase. So if you have customers or if you want to try it yourself, contact me after this session. The second thing that we're doing is CloudGuard WAP. Basically, WAP is more than just a web application firewall. It has the capability of protecting your web application from threats like cross-site scripting and SQL injection, but it also has an API enforcement capabilities, meaning that you can give us the API descriptive document, the Swagger file, and we will make sure that the entity that calls your API will use the right parameters. So for example, if you have an application an API that gets integers and someone is trying to concatenate a malicious command into this integer, we will block it. And we also have a bot mitigation capability. It's one of the nano agents in Infinity Next. So basically, you can plumb it to the ingress controller. You can plumb in Kubernetes to any container. So it can run inside the container itself or on the API gateway. And it doesn't require any configuration. Okay? It is built on machine learning. So we learn the application. We learn all the APIs. And then we enforce it. The idea is that we know that one of the challenges in WAF is to configure the rules to match the application. And it's a constant race. Here, you don't need to configure anything. We learn it and we enforce it. And we have a session about CloudGuard WAP. I'm going to show you the agenda later on. So go and see it. The next section is network security. And in network security, when we talk about cloud-native technologies, we have three options to deploy network security. The first one is to use the native controls. The second one is to use security gateways, and the third one to use dedicated agents for network security. Let's start with the native controls. So we have right now the ability to manage security groups. And I will show you in a second how it looks like. We are adding now the ability to control native security in Kubernetes. So basically, last year I talked about the different security controls that you have in Kubernetes. So I will just remind you the basic security policy that you have in Kubernetes. It's called the network policy. And you can define it. It's allowed rules only. So the only option you have is to define what you are allowing to get, but you don't have drops and you don't have logs and you don't have a lot of capabilities that we are used to have. And then Calico network policy is enhancement. It's extending these native security. Calico is the network it's the underlying network in Kubernetes. It's one of the options, but it's the most common one. So like 80% of the market is using Calico. All the public cloud vendors are using Calico. So this is why we are starting with managing Calico. So if you want, please join the EA and see it yourself. This is how we manage and visualize security groups. So here you can see the different security group per assets, and you see the relationship between them and which one is external and internal, etc. If we talk about, on security gateways, we are doing it today. We have an advanced threat prevention capabilities that runs in multi-cloud, CloudGuard IaaS, and last year we released these two important things. One is the Kubernetes aware policy. It's the ability to define a policy, a north-south policy, which consumes the inventory from your Kubernetes environment and updates it all the time. And then we are able to protect PaaS services using a network constructs. The last item is agents, and this is something that is on our roadmap. I'm kind of running fast because I started late and I had this issue with my laptop. The last thing before I hand it to Zion is the log analysis. And I have a dedicated session on logic just in 10 minutes. So if you want to hear more about logic, stay for the next session. You can see here that we added recently the ability to visualize it in Kubernetes. So basically here what you can see is that we are deploying our own pod that creates the flow logs, and then we visualize it, and you can clearly see how pods are communicating with each other. And we are going to add the activity logs. So all the API calls that you have in Kubernetes are going to be part of logic. And so I know Zion for 20-something years, so it's hard for me to call you TJ.
I go by TJ, by the way. The Zion thing, I gave it up like 10 years ago when I moved to the US. It's way too hard. Can you hear me, by the way? Yeah, it's okay, I'm loud enough. Listen, so forget slides. Let me tell you what we do because we have like a few minutes. So I was one of the founders of a company called Protego Labs. We founded it a couple of years ago focusing on serverless security. So if you're doing containers, then you know that it's sort of old news already because the world is moving to serverless. What is that? Oh, thanks. Okay. So serverless functions, for the ones of you that haven't had the opportunity to deal with it, it's these, think about them as pieces of code that you don't need to manage, right? You write a piece of code, you put it in the cloud, you need it to run 100 billion times, Amazon will take care of it. You don't need to take care of scale, automation, all that stuff. It just magically happens. The biggest problem with these type of environments, like Amir said, they move really fast, they change really fast, and really, if you think about protection, where do you put it? It's a piece of code. So anyway, so the Protego solution came in, and we actually had two parts to our solution. We have a posture management solution, and we have a workload protection solution. The posture management, to keep it super simple, automates configuration for these functions. So we take a piece of code, a function, we read it, we analyze it, and we automatically understand what this piece of code can and cannot do. And what we do with that piece of information is we automatically generate what's called in the cloud configuration world an IAM role, permissions. So think about it like that. Someone wrote a piece of code, you're a developer, our technology takes it, reads it, and says, I got it. You only need S3, you only need these two API calls, you shouldn't be able to access the outside world, you shouldn't be able to launch a sub-process. And we automatically generate this IAM role. And then you can take it as part of your CI/CD process, plug it into your console, and you're good to go. In addition to that, we also scan the code for vulnerabilities and a couple of other things. Then,
In runtime, what we'll do is we'll attach a piece of code, and I talked a bit about that today. We'll attach a piece of code which we call function self-protection. Sort of what Gil talked about a nano agent. And it attaches itself to the function. Once it sits inside the function, it will inspect everything that comes into the function for attacks, but it will also learn what the function can and cannot do because we already read the code, and will automatically enforce a policy based on that. On top of that, you can write your own rules to say what you want this thing to do or not do. All of this, what you need to remember from this is that if you deal with serverless, and I know some of you guys do, you have Lambda functions, it's a mess. It's not your world anymore, it's a developer world. We automate that part of configuring security and protecting it while it goes. That's what you need to remember. If you want to see a demo, there's in the tech session, there's a really cool, it actually looks really cool, by the way. If you want to see a cool thing, it looks really cool. It looks like this. Come on. That is cool. Coolness factor 10. So there's guys there that are demonstrating it if you want to see how it looks like. And I would say this, listen, this is the future of security, generally speaking. This is the future. This is how it needs to look like. And this is how you guys need to think. If you're not in the cloud now, you'll be in the cloud tomorrow. If you're not in containers now, you'll be there tomorrow. If you're not in serverless, you'll be there tomorrow. And if you're not ready, you're going to be behind. Someone else will be. So anyway, go check it out. Oh, you have your own thing?
Yeah, I have my own thing. Bring your own microphone. Okay. So basically, we added two members to our CloudGuard family to protect your cloud no matter where you are in your journey. And everything will be managed from Infinity Next. So the idea is that all these capabilities, at the end of the day, will be managed from Infinity Next. And we have like half a minute. So go and learn more about cloud security and what we're doing. Here you see the full agenda. That's it, basically, yeah.